Hi folks, we're going to take a look at page 61, number 17, one of the questions that was requested. So the question essentially gives us two vectors. One vector is 2a plus b, the other vector is a minus 3b, and they tell us that they're perpendicular, and we want to find the angles between the vectors a and b, given the condition that the magnitude of a is equal to 2 times the magnitude of b. Okay, so let's be very clear here that it's 2a plus b and a minus 3b are perpendicular. Okay, we can't assume that the vectors a and b themselves will be perpendicular. And, well, we'll see what happens as we solve the problem. So first thing I notice here is I've got two vectors that are perpendicular. So the first thing that should come to mind is that their dot products will be equal to 0. So that's how I'm going to start this problem. So I've got 2a plus b, okay, dotted with a minus 3b has to be equal to 0. So I've got this equation, so let me see if I can simplify it. That's always the first step. So because of the distributive property of the dot product, I can distribute this similar to the way I would do a product of binomials. So I've got 2a dot a, okay, the first one, and then the second one I've got minus 6a dot b. Okay, then here I've got plus b dot a, and then finally I have negative 3b dot b. Okay, and all that is equal to 0. So let's see if I can simplify. So now another property of the dot product is that a vector dotted with itself is just the magnitude of that vector squared. So let's start simplifying here. So I know that a dot a is the magnitude of a squared. Okay. I also know another property of the dot product is that it's commutative, meaning that a dot b is the same as b dot a. So I can combine these two terms. So I have negative 6 plus 1. I have minus 5 a dot b. Okay. And then here again, b dot b, vector dotted with itself, is just going to be the magnitude of b squared. And that's still equal to 0. Okay, so we've got, still have the variables vector a, vector b. Let's see if we can combine stuff together. Well, I know that the magnitude of a is 2 times the magnitude of b. So wherever I see the magnitude of a, I can just replace that by 2 times the magnitude of b. And since I have some relationship between the magnitudes of the two vectors, and what I'm looking for is the angle between them, it makes sense to apply the geometric definition of the dot product, because that contains the magnitudes and the cosine of the angle, which is what I'm looking for. So in the next step, let's use the properties that we have. So here I know that the magnitude of a is 2 times the magnitude of b, okay, and all that is squared. Okay, here I've got 5, and a dot b is the magnitude of a times the magnitude of b times cosine of the angle between them, minus 3 magnitude of b squared. Okay, so here, if we simplify this, this ends up being 4b squared times 2. So here I've got 8 times the magnitude of b squared. Here 5 times, well, remember the magnitude of a is just 2 times the magnitude of b. Okay, magnitude of b cos theta, and then here again minus 3 magnitude of b squared. Okay, I see I can combine the first and the last term. Okay, so I've got 8 minus 3, so that's let's get that out of the way. Got 8 minus 3 is 5 times the magnitude of b squared. Okay, and here we can simplify this, so I got minus 10. Okay, and here again, magnitude of b squared times cos theta, okay, equals 0. And now I look at these two expressions, and I see that there's a common factor. They both have a common factor of 5, and they both have a common factor of b squared. Okay, so when I remove that, what am I left with here? I'm just left with 1 minus 10 divided by 5 is 2. Magnitude of b squared is gone, and I've got cos theta equals 0. Okay, so I've got the product of two expressions equal to 0. We're going to use an old trick. We know that either the first expression has to be equal to 0 or the second expression has to be equal to 0. Okay? Now, they didn't actually tell us that A and B were non-zero vectors, but since we're looking for the angle between two vectors, it's safe to assume that they're not looking for the scenario where B is the 0 vector. So we'll assume here that 1 minus 2 cos theta has to be equal to 0. But if I do a little simplifying here, I end up that cos theta is just equal to 1 over 2. And we should recognize that as corresponding to one of our special angles. So I'm not even going to get my calculator out. So if you don't remember it off by heart, well, you should hopefully remember that it's either the 30-degree triangle or the 60-degree triangle. It all depends on how you draw it. So let's draw it out. We know that the hypotenuse has to be equal to 2. And since this is cosine, it means the adjacent side is the shorter one at 1. And so it looks like what we have here is the larger angle, so theta must be equal to 60 degrees. Okay, so just to recap, the first thing we did is we used the property that perpendicular vectors have a dot product of 0. Okay, then I used the distributive property of the dot product. Okay, then from there I used a couple of relationships, that dot product is commutative and that a vector dotted with itself is just the magnitude squared. And then I inputted the relationship given, that the magnitude of A was twice the magnitude of B. And from that point forward, it was really just an algebra problem. Okay, in fact, turned into solving a very simple trigonometric equation. Okay, so that's the solution for that one there, theta, 60 degrees.